Any questions that you'd like to see worked out? I had one question earlier that might be beneficial to everyone. Notice number 7 asked, verify that they're similar, and then find the scale factor of ABC to DEF. So as soon as you do that, if you're going from ABC, then BC, which is 18, goes with EF, which is 12. Do you agree to go from 18 to 12? You're going to need a fraction less than 1, a proper fraction, right? And so when you reduce, you always do new divided by old, new divided by original. This is the new. You're going 2 to EF. 12 divided by 18. What'd you get? 2/3. Okay, so the scale factor K would be 2/3. Okay, if I said what's the ratio to go between them, it could have been 2/3 or 3/2. The scale factor is 2/3. All right, any questions on any other ones that are confusing, challenging? We just like to see them worked out. Did I give you guys number 3 or 4 or both?
4.
How did we do on number 4? Do all right? Cool. Any other questions for me? All right. So today, let's refresh. What are the ways that we can show that triangles are similar? I heard SAS. I heard AA. And SSS. Are there any others? Those are correct. Those are the 3 that we're going to use to show triangles are similar. Does that make sense? All right, let's talk about how can we apply these theorems to 2-column proofs. Our first proof for today. Let's take a look at it, understand what's going on here. I can see a triangle kind of nested inside of another one. We're given AB is parallel. Ooh, parallel. We know some things happen when we see parallel. So first, we're going to write down BD parallel to AE. Given. BD parallel to AE. And then I kind of look, now this one's easy because there's only 2 triangles. There's triangle BCD and there's triangle ACE. It's not that confusing which triangles they're talking about. In a proof coming up, there will be quite a few triangles in the picture. So kind of identify which ones you're heading towards. Help me out. You guys are going to kind of steer the ship today. You got this. This is review. Paige.
Angle C is congruent to angle C.
Good. Is it okay to call it angle C in this case? Or should we call it like BCD? What do you think, Paige?
I think angle C.
I think angle C is fine in this one. Because there's only one angle overlapped at angle C. Do you agree? If you wrote angle BCD, I'm fine with that. The center letter has to be C. Right? Angle C, congruent to angle C. And Paige, what would your reason be for that one?
Reflexive property.
Good. Who else can help me out here? What kind of?
Would angle A be congruent to angle CBD?
Angle A congruent to angle, what did you say, McKenna?
CBD.
Perfect. Good job. CBD. Oh, do you have a reason for that, McKenna, or do you need some help?
Consecutive angles.
And
Not consecutive. Corresponding.
corresponding. Yep. that Jackson helped out?
That was all my own.
He's got all the directions for that. Yeah, page.
Would you do angle A is you go with angle D by alternate interior?
Not in this one. What do alternate interior look like? Well, there has to be parallel lines, which I see. But there would have to be a transversal, like with like alternate interior. Like, and there's just no transversal drawn there. Right.
Could you also have corresponding for B and D?
What do you guys think? We didn't say it, but could these be congruent by corresponding angles? Yes. Okay. Now, do we need to say that? No, I know you guys. You don't want to do any more work than you have to. So let's stop there. Ooh, that was kind of mean, wasn't it? A little harsh. All right, what do you think? Are we ready to say that they're similar?
Yeah.
So triangle BCD, similar to triangle ACE. And what would our similarity theorem be? AA, very good. We didn't talk about any sides in this one being congruent. Or, sorry, proportional. You guys see how a similarity proof would go? Pretty similar to the congruent proofs, huh? Let's try this one. Go ahead, write down the givens. We're kind of getting more mature with our proofs, aren't we? We're kind of like progressing with our understanding and kind of able to see ahead a little bit, I would say. Would you guys write all of these givens on the same line, or would you put separate lines?
Center, extend attention to all students attending the University of Akron District. Please report to door 9 by the guidance office now. Thank you.
How many of you would write these all on the same line? How many of you would separate them into 3 separate lines and put given, given, given? Okay, that's preference. That's fine.
I would try to write it down.
When I say like write it on the first line, I don't mean like is there enough room to write it on the first line? I mean, could they go on the same line? Yes. All right, so M is midpoint of JK, N is the midpoint of KL, and P is the midpoint of JL. Those are all given. Why do you think they're handing us that information? What is it called when you connect the midpoints of all the sides of a triangle? Do you remember what those segments are called? Do you remember what that triangle's called? And then we'll talk about what are the relationships created. Let's back up. Does anyone remember what MP is called, or MN is called, or PN is called? When you connect the midpoints of the sides of the triangles. That was in the same section. Jared.
Mid-segment?
The mid segments. The mid segments. So MP is a mid segment. Don't write this. You don't have to write that down. I mean, we're not going to put that in the proof, but you can write it down if you forget. It's called a mid segment. All right, if you want to write that down in your notes, that is called a mid segment. There were 2 results that happened when you have a mid segment. The mid segment was, you remember, Jared? Want to keep it on a roll, or do you want to pass it off to someone else?
Isn't it half the length of
Good. It's half of KL. Good. And it's parallel to KL. Remember that?
Yes.
And this little triangle in here, MPN, is called the mid-segment triangle. Okay, it's called the mid-segment triangle. that was, but just to kind of jog your memory, I don't know about you guys, but if I can kind of remember back to what we were doing at the time, it helps me remember some of the stuff around it. That's the one where I cut out the whiteboard, the laser cut whiteboard triangles. Remember those ones? And we had little midpoints. We drew in medians. A median did what? Connected the midpoint of a side to the vertex. A mid-segment connected the midpoints. Okay, didn't go to a vertex of one of the angles. It went to the midpoint of another segment. That was the difference. Okay, well, wait a minute. Before we just write a bunch of stuff down, there's two things going on. There's half the length, and there's parallel. Ooh. We have a couple things that happen when we have parallel and half the length. Now, Paige, we'll go back to your comment earlier. If these segments are parallel, could I say these are alternate interior angles? Yes. Will that help me? This, and I'm kind of getting ahead of myself. I kind of broke my own rule. I'm getting excited about all the math here. What two triangles are we trying to show similar? JKL, the big one, and NPM. NPM, the inside one, right? The mid-segment triangle. So before you get too far, don't just write all the stuff down that you know. That would be too messy, all right? It's kind of like, I kind of use the analogy when you're writing a paper for English. I think your teachers get really annoyed if you just write a bunch of stuff and it's not well thought out and it's like all over the place. And it's just like you just wrote down a bunch of information. It didn't really have any flow to it. It didn't really make sense logically. It's kind of like how proofs go. Like if you don't give way more information that's needed, try to think of the best way to get from start to finish. All right. Well, are alternate interior angles going to help me here? No, because this angle is in that triangle. This angle is not in the red triangle that I'm trying to match up. Okay. What about corresponding angles? That probably wouldn't help me out either, would it? Do you agree? So even though we know from Jared's comment earlier that they're, well, you said half the length. Someone else said parallel. I don't want to give Jared too much credit. I'll get a big head out walking out of here. But he said half the length. We also know parallel. That doesn't mean you have to use all that information. Tally, what do you think?
Couldn't you use the alternate interior angles, but then also say PNL is congruent to...
Hold on one second. Let me get rid of these ones so we're not confusing the picture too much. Okay, go ahead.
Couldn't you say PML is congruent to...
NL, okay.
Is congruent to JKL because corresponding angles?
JKL. But this angle right here isn't inside of that triangle.
That's, yeah, but like, couldn't we move it over with corresponding angles?
Like here?
To JKL.
JKL. I'm okay with JKL. This angle is in the triangle we're trying to prove similar. But we would want to match it up with one of these angles inside of this triangle.
Yeah, so it'd say MPN is congruent to JKL. Because
Okay, why?
alternate interior angles, then corresponding angles.
And then you would use the transitive property. So this is congruent to this by alternate interior. And then this is congruent to this by corresponding. And so therefore K is congruent to MPN by the transitive property.
Yeah.
That would work. It would take 3 steps to get there. I'm not saying it's wrong. Just take maybe more steps. Do we all agree that if we wanted to use alternate interior, it might be a little bit forced? Like we could make it work, but it would take a few steps to get there. Do you guys agree with that? So let's go back to the other fact we know about the mid-segment. All right. Jared. Pn is what compared to Kj? 1/2. How would I write that in an equation? Pn is half of Pn. I think I said it backwards, but Jk. Do we all agree with that? I'm not writing in my proof yet. This is kind of like my pre-writing step. Okay. Do you agree with that? What about MP? MP is half of KL. MP is half of KL. Okay. What about MN? MN is half of JL. How is that going to help us or not? I don't know. How's that going to help us? Christiana, go ahead.
Because they have a scale factor of 1.
They have a scale factor of 1/2. If the sides are, 3 pairs of sides are proportional, then the triangles are similar by SSS. So do we agree we could probably get there with alternate interior or corresponding or transitive properties, but it would take 3 steps for 1 pair of angles? Do we agree this is probably a lot shorter? Do you agree? Okay, let's put that on our line. Pn is half of Jk, comma, MP is half of KL, and Mn is half of JL. What would our reason be for that? What fact did we use? The mid-segment, yeah, the triangle mid-segment theorem. The triangle mid-segment theorem. Is that enough information to say these are similar now, or do we need more? You think it's good? Triangle JKL similar to triangle NEM by SSS similarity. I bet some people might feel like after step 2 they need to say that that makes the sides proportional. So if you like really felt the need to say that, you could put like a line that said scale factor of 1/2. Okay. That's the definition of a scale factor, is if you can multiply one segment times a factor, half, 2, whatever it is, to get another one, they are proportional. Okay, you could say all 3 pairs of sides are proportional with a scale factor of 1/2. Definition of scale factor. That'd be fine if you really felt like it. But this is good. Does that make sense? All right. This is a little fill in the blank, so I want you guys to try this one. I want you to try it on your own. Just a little checkpoint. What did you guys put for step 2? The reason for step 2. A hint, this goes way back to like algebraic proofs before we even did geometric proofs. What did they do to both sides? Levi?
Division property of equality.
Ooh, Levi. Yeah, it's been a while. The division POE, property of equality. Callie.
How is it the division property of equality?
It looks like they divided both sides by 3. And then it looks like they divided both sides by RT. Do you want to see it? 3 times UT equals 5 times RT. If I divide both sides by 3, I get UT equals 5/3 RT. Are you with me so far? If I divide both sides now by RT, pretend that's a T. I get UT over RT is 5/3. Does that make sense? It was 2 division properties of equality. They just did it in one step. So division property of equality will be fine there. So what do you guys think step 4, the reason is? To go from step 3 to step 4.
Given.
Step 3 was given. How'd they get to step 4, do you guys think? Division property of equality, good. All right, why is angle RTS congruent to angle VTU? Vertical angles. And so what they really did here was they said VT over, where am I? VT over ST has a ratio of 5:3. Then they said, before that they said UT over RT has a ratio of 5:3. Oh, look. 2 pairs of sides are proportional. Good. Proportional. What kind of angle where they meet? What's that word again? Starts with an I? Included angles are not proportional. They are congruent. Therefore, the triangles are similar by SAS. If you feel like you need to write similarity, that's fine. Tell you what, I mean, once you have practiced it and you write the correct symbol here, you put there similar, then I know when you say SAS, we kind of had this conversation yesterday. Should I put SAS similarity or should I just put SAS? Once we're kind of into it and you write the similar symbol here, when you say SAS, I know what you mean at that point. Okay. You guys like the fill in the blanks where they give you the reasons you have to put the statements, or do you like to do them yourself?
Nice.
Kind of depends. All right. Try this one on your own. I'll give you a hint. We don't know any segments are parallel in this one. Do you guys like Civil War jokes?
Sure.
I generally don't find them funny. That was today's joke. See the one Brooklyn left me?
Yeah, I saw it first. Yeah,
Do you want to share it? Do you think the class will find it funny? Go ahead, Jackson.
Sitting in the corner is really hot. It's like 90 degrees.
Sitting in the corner is really hot. It's like 90 degrees. Unfortunately, that joke doesn't work very well in the school. That corner is 90 right there. That corner, but like these angles are actually pretty close to 180, aren't they? They're really hot. 180 degrees. What do you think that angle is in that corner?
That's up like Arizona summer.
All right, we got J L, a third of J N, so those sides go together. Then we've got J K, seriously, is a third of J M. Those ones are proportional. That's not enough. There's no such thing as SS similarity. What's missing? You got this.
Angle J.
Angle J.
Is congruent to angle J.
Angle J congruent to angle. Congruent to angle J. What's the reason there? Reflexive property. Therefore, triangle JKL similar to triangle JMN by SAS. Very good. That was a short proof. You heard proof day, and you guys kind of got cringes, didn't you? I cringed a bit. It wasn't that bad, was it? Anthony. No, because we don't know it's a mid-segment. It's actually not a mid-segment.
Can you show me the other ones that was mid-segment?
Yeah, hey guys, question real quick here. Why can't we use the mid-segment theorem here? JL is, okay, point L is what? A third of the way. It's a third of the whole thing. A mid-segment is half the way. So that's why I said you can't use parallel here. You can't use parallel or alternate interior, corresponding, any of that. We're not showing these are parallel. So your mid-segment one was here. All right, this worksheet you have in front of you is for homework. Yes.
I have a question on my house.
Yes. Let me stop the recording real quick.